Hi there! Today in this lesson we are going to be looking at how to find the volume of cylinders and prisms. Now, the formula for volume for cylinders and prisms is area of the base times the height. So when you're working with a cylinder, the base is a circle. So the area of the base is pi r squared. So to find the volume for a cylinder, we're going to take the area of the base, which is pi r squared, times the perpendicular height to the top. So write this down in your card. This is the volume for a cylinder. Volume equals pi r squared times the height. All right, volume for a prism is the area of the base times the height. Now here I can't give you a different formula necessarily because it depends on the shape of the base. So first you're going to find the area of the base and then take that times the perpendicular height. Now keep in mind the base of a prism is the shape where you have two of them that are congruent and parallel. So you have, this could be your base right here because you have another side that is congruent and parallel. You also could use this as the base right over here, but if you did that, then this would be the height. The height, think of the height as the distance between the bases. Okay, that is your perpendicular distance between the bases. Okay, so let's do one of these. Find the volume of the solid. So volume equals area of the base, that's what big B is, times the height. Now this is a, let's look at this. We have 1, 2, 3, 4. We have a, looks like a trapezoid. Yep, it's a right trapezoidal prism. So we're going to find the area of the trapezoid. Now if you recall the area of the trapezoid, that formula is 1/2 times the height of the trapezoid times the sum of the bases. So that's the area of the trapezoid, and then take that times your perpendicular height, which would be 5. So let's just look at the area of the trapezoid. Now if this side is 6, this side is 6. So the two bases of the trapezoid are 14 and 6, and then the perpendicular height is 3. So that's the height of your trapezoid. So that would be a 3 right here. And then the bases would be 14 plus 6. And then you take that times 5. Okay, so then we have 30 times 5 is 150. And that would be volume. And volume, you have length times width times height. Basically, that is units cubed. Volume is units cubed. Next one, the volume is the area of the base, which it's a cylinder, so the base is pi r squared, and then times your perpendicular height. So it's pi times 9 squared times the height, which is 6. So pi times 81 times 6 is 1,526.8 approximately. And that would be feet cubed. Okay, then just a few theorems here for you to look at. I'm going to grab a drink quick. The main one is volume of a cube. Now, and it's a cube, it means that the base is a square. So if this is S, this is S. So if we were using the other formula, area of the base times the height, well, the base is a square, so that would be length times width, or base times height. That would be side times side to get the area of the base, and then times the perpendicular, the height, and that would also be S, and so that gives you S to the 3rd power. So that's the area of a cube. Also, I want to talk about the volume addition postulate. You'll be using that in this lesson. The volume of a solid is the sum of the volumes of all of its non-overlapping parts. So basically, if you have a cube, and let me see, there, something like this, and you had to find a shape like this, the volume of this type of shape, you would find the volume of this one and the volume of this one and add them together. All right, so let's use this. Now here's an example. Find the volume. So again, volume is area of the base times the height. The big thing is here is you have to determine the base. Remember, the base is the two shapes that are congruent and parallel. And so we have a triangle here. Let me get my little highlighter here. Triangle here. And you have a triangle here. So these would be what we would consider the base. So we're going to find the area of the base. Now this is a right triangle right here. And so the formula for the area of a triangle is base times height divided by 2. And so the base of that triangle is 4, the height is 3. So that would be 12 over 2, which is 6. So the area of the base is 6. And the height, that is the distance between the two bases. That would be 6. So that would give me 36 inches cubed. Now, it can be confusing because we always think, well, it has to be sitting on the base. But you have to understand the base is the same shape throughout the whole prism. Okay? And so you have a triangle. If you were to cut this, this would make a triangle right here. If you cut right here, right down the middle, it would make a triangle. So you'd have a whole bunch of little triangles stacked together. All right, next one. Find the volume of an oblique cylinder. Now, the volume of an oblique shape is the same. Cylinder, the formula is the same. It's area of the base times the perpendicular height. So area of the base is a circle, so pi r squared. And the perpendicular height from the base to the top is 7. So it would be pi times 4 squared times 7. Which is 16. You get 351.9 approximately, and that would be centimeters cubed. Okay, next, find the volume of the solid. Now this one's interesting because we have a triangular prism, because notice you have a triangle here. Okay, so this is what we're going to consider the base of the figure, and then you have a triangle in the back that is parallel and congruent to it. So that's the base. Even though it's sitting on a rectangle, you don't have another rectangle that is parallel. So the base is a triangle. So we're going to find the volume of that triangular prism, and then it is hollowed out by a rectangular prism. So we're going to find the volume of that and subtract it. So the volume of the triangular prism, so that would be area of the base times the height. So let's look at the area of the base. So we have this triangle right here. I'm just going to draw it separately. We know that this is 10, and these sides are congruent. So this is 10 also. But we don't know the height, so we're going to have to drop a line down, okay? And we could use a Pythagorean theorem. We have to find the height. So we'll do x squared plus 5 squared equals 10 squared. So then x squared equals 75. And the square root of 75 is equal to 8.7 approximately. So this is 8.7. So the area of the base, it's a triangle. It's base times height divided by 2. So the entire base of the triangle is 10. The height we found was 8.7 divided by 2. And that is 43.5. So to get the volume of the triangular prism, the area of the base is 43.5. The height, that is the distance between the bases, that is 6. So you get 261. That's the volume of the triangular prism. All right, now let's find the volume of the rectangular prism? Again, area of the base times the height. Well, let's see. The base, they tell us that this is 3, which means that this is 3. So the area of the base is 3 times 3. Okay, that's the area of this. And then the height is the distance to the other side, which would be 6. And that would be 54. All right, so that is the volume of the rectangular prism. So to find the volume of the solid then, we're going to take the volume of the triangular prism, which is 261, minus the volume of the cutout, the rectangular prism, and we get 207, and volume is feet cubed. So we had to do lots of steps there. Okay, so this is the worksheet you're going to be doing today. So you have to find the volume of the prisms. So again, determine the base. Let's go ahead and do this one right here first. So the base here is the triangle because you have 2 parallel triangles. So volume equals area of the base times the height. So let's find the area of the base. And in this case, the base, like I said, is a triangle. Okay, and so that's base times height divided by 2. So 4 times 10 and divided by 2 would be 20. So the volume of the base is 20. The height is the distance between the two, and that would be centimeters cubed. All right, and then here's another one, number 4. This is a lot like, I'll just talk about this for a minute. It's a lot like the problem that we just did. We have to find the base again is a triangle. And we know that this side is 10, but we need to find the perpendicular height. This side is also 10, so this would be 5. And if we do the Pythagorean theorem, these are the same numbers as we had on that last example. This was 8.6. And so the area of the base, so the base would be triangle, so base times height divided by 2. So the entire base is 10, the height is 8.6, and then divide by 2. So to make sure that I remember those numbers correctly. Or, 8.7, I wrote it down wrong. Let me fix that. It should be 8.7. So you get 43.5. So the area of the base then is 43.5. And then the height, which is the distance between them, is 8. And then you can just multiply that out and you'll have that one done. All right, let's go ahead and do number 6 because we haven't done a problem like number 6 for a while. That is a volume problem again, and this time we have a pentagonal prism because the bases are the shape of pentagons. Okay, so we have to find first volume equals area of the base times the height. We have to find the area of the base. So remember when we find the area of regular pentagons, what we want to do is break it into congruent triangles. All right, so we have to find the area of one triangle and we multiply that times 5. So 2.8 is the height right here. So the area of a triangle, base times height divided by 2. So the base, this length is 4. The height is 2.8. They gave us a lot of information divided by 2, which would be 2 equals 5.6. So that's the area of this triangle. And then so we have to lastly multiply that by 5. And you get 28. And so the area of the entire base is 28. The height, the distance between the two bases, is 6. And you get 168. Like that. All right, let's look at the next page. Find the volume of the right cylinder. Round your answer to 2 decimal places. Okay, so volume is area of the base, which in a cylinder, the base is a circle, so it's pi r squared times the height. So we have pi. And then we have to look at what is the radius. It's the distance from here to here, which would be 11. And the height is 16. And that is 6,082. And that would be feet cubed. All right, here we have to find the volume of the solid by determining how many unit cubes are contained. So I just want to give you a hint right here. So on this one, what we're going to do is find the volume of this rectangular prism, and then find the volume of this one and add those together. Now we have to do some figuring. We know that this is 5, which means this is 5. So from here to here is 5. That means that this is 4. All right, and this distance right here is the same as this, so this would be 4. So this would be 4 times 4, basically. So the area of the base would be 4 times 4. The height would be 5. And then you're going to do this one right here. Your base here is 5 times 4, so that would be 20, and then times 2. With this one, I want you to try this one. We're going to find the volume of this one, find the volume of this, and then we have to find the volume of this and subtract that from the sum of the other two. All right, and that is all we're going to look at on this video. Thanks for watching, and let me know if you have questions.